Hello everyone, welcome to Palle AI. My name is Sridhar Palle. Single most mission for me and this channel is to empower everyone in understanding AI and related tools and technologies. My hope is to inform, train, and guide with respect to the latest developments happening in this field so that everyone can take advantage of this transformative technology, either to change your lives, future-proof your career, or basically to apply AI for enhanced productivity. In this video, I would like to demystify some of the core technological concepts related to AI. What is AI? What is machine learning? What is deep learning? How are they all connected? Let's find out. Okay, so what is artificial intelligence? Before we try to define what artificial intelligence is, let's first try to understand who are we and what do we mean by intelligence. So who are we? Well, we are humans, or as we cleverly like to call ourselves, we're the Homo sapiens, we're the wise men. So where is this so-called wisdom of ours coming from? It's coming from our intelligence. So how do we define the human intelligence? Well, human intelligence can be defined as our ability to perceive, think, learn, reason, predict, and manipulate a world far more larger and complex than ourselves, hopefully for our betterment. So this is human intelligence. So now it becomes easy to define AI or artificial intelligence. So what is AI? It's the design and creation of artificially intelligent entities that we have created that can also perceive, think, learn, reason, and basically act like humans would do. Okay, so this is artificial intelligence. But how does these artificially intelligent entities look like? Well, they could be something like robots used in manufacturing, agriculture, healthcare, or in many other industries. Or it could be a piece of software in the self-driving vehicles. Or it could be the smart assistants like Siri and Alexa. Or AI entities could be like the recent breakthroughs in chatbot technology like ChatGPT. Okay, so we have defined what AI is and how these intelligent entities look like. Next, we're going to take a look at what comprises the AI tech. Okay, so what comprises AI technology? Well, AI is not any single technology. It's a very broad-based field and it's a collection of multiple technologies that enable computers or machine to perform complex tasks that would normally require human intelligence. During the 1950s to 1980s, whenever AI was mentioned, it was primarily symbolic AI. Symbolic AI was a dominant paradigm of that time, and it involved hard-coded rules and explicit logic and didn't qualify as any type of learning. At that time, it was widely believed that human-level AI could be achieved through symbolic AI by having programmers handcraft explicit rules for manipulating knowledge stored in explicit databases. While it served its purpose at that time for well-defined logical problems like playing chess, it was found to be intractable for more complex problems that required human intelligence. For example, problems like speech recognition, image classification, or natural language understanding. Well, this paved the way for the modern day machine learning. Since 2012, machine learning has become the face of AI. In fact, many practitioners in the field of AI like to joke that AI is nothing but a fancy word for machine learning. Machine learning in a suit is AI. Okay, so if machine learning is the face of AI, what is deep learning? Well, deep learning is a subset of machine learning, particularly a branch of machine learning algorithms called neural networks. In fact, out of all the machine learning algorithms, neural networks have become so popular for computationally intensive problems like computer vision or natural language understanding, they carved an entire field to itself called deep learning, or basically deep neural networks. In fact, deep learning is the one which is primarily responsible for, in a way, making machine learning the face of AI. Okay, before we try to understand what deep learning is, let's try to understand what machine learning is and what makes machine learning so special. Let's take a look. To understand machine learning, first let's take a look at how traditional computer programming works. When it comes to traditional computer programming, just like symbolic AI, we have to provide explicit rules to get the computer to do any meaningful work. Well, this would mean we have to give it explicit rules and the data so that we can get the computer to give us the answers that we want. We are the ones who are doing all the hard work here in terms of providing it explicit rules. Let's try to understand this with respect to an example. For example, let's say we want to develop an activity recognition software using traditional programming. How would we approach this? Well, a naive way would be to come up with explicit rules that can define each activity. For example, this would mean if the speed of a person is less than 2 miles per hour, the activity is walking. Or if the speed is between 2 and 6 miles per hour, the activity is running. If the speed is greater than 6 miles per hour, the activity is cycling. So the problem with this kind of approach is we have to keep on coming with explicit rules for all kinds of activities, all kinds of scenarios that we want the computer to recognize. What if the computer sees an activity or a scenario that it has not encountered before? Well, it will get completely confused because it doesn't have an explicit rule for that. It doesn't know what to do. This is the problem with traditional computer programming approach. See, now the beauty of machine learning is it completely turns this paradigm around. Instead of expecting explicit rules from us, all it wants is a lot of data and a lot of answers. By looking at a lot of data and a lot of answers, it will come up with its own rules. And in the process, it becomes smarter. In this context, we call machine learning a trained system rather than an explicitly programmed one. Now let's take a look at the activity recognition example again, but now with machine learning. How would we define this with machine learning? Well, instead of giving it explicit rules, what we would feed the machine learning system is the lots of different images of the activities and the corresponding tags or labels. For example, image of a person walking and the corresponding tag called walking. Image of a person cycling and the corresponding tag cycling. So we keep on providing a lot of images and the corresponding tags or labels or answers. And we feed all this data to the machine learning system. Machine learning system looks at all these different images of different activities and also the corresponding tags like walking, cycling, running, playing, and so on. And in the process, it will come up with its own rules and in the process becomes very, very smart or learned. Once a machine learning system has become smart or learned, you give it a new image or new activity and it will correctly tag it as, in this scenario, the tag is playing. So this is the beauty of machine learning system. We don't give it explicit rules. All we give it is bunch of data and bunch of answers, and it will come up with its own rules for figuring out or tagging any new activity. So think of machine learning system just like a seasoned individual or an experienced person. For example, for a project, let's say we want to hire somebody. What do we typically look for when we are trying to hire somebody? We look for the most seasoned or most experienced guys. Well, what do these experienced guys or seasoned individuals are bringing to the table? Well, they have seen a lot in life, right? Through all their mistakes or their triumphs, they have seen a lot. At the same time, they have learned a lot with what good examples and the bad examples. And in the process, they become smarter. Well, a machine learning system is just like that. It needs to see a lot, both good and positive and negative examples. And in the process, it will become smarter. And once it becomes smarter or learned, you give it some new task. Well, it will be able to predict with reasonable accuracy. Well, this is machine learning. Let's take a look at machine learning much more closer, much more deeper in the next slide. To understand machine learning more clearly, let's look at an image classification example. Let's say we want to design a machine learning system that can automatically classify many different raw images into 4 different classes. Classes of cats, babies, men, and women. Let's say for demonstration purposes, we use this example. We have also seen earlier that a machine learning system needs to see a lot of data and a lot of answers or labels before it can come up with its own rules. Let's call this raw data as X. Let's also call these answers or labels as Y. So how should this raw data X look like for the image classification system we have in mind? Well, our system is trying to classify raw images. So the data X is nothing but raw images. We start with a bunch of images of cats. For each of this image, we have a corresponding label of cat. Similarly, we have a bunch of baby images and we have corresponding labels for the baby images. And we have images of men and we have the corresponding labels. And similarly, we have images for women and we have the corresponding labels for the women images. Now, our machine learning system says all of this raw data X and also the corresponding answers or labels corresponding to each of this image, the Y, and then it will come up with its own rules, and in the process, it becomes very smart. So what exactly is this rule which the machine learning system is trying to learn? Well, think of the rule as a mathematical mapping between Y and X. It is trying to come up with a formula. If it helps, think of it like a formula or an equation or a mathematical relationship between Y and X by selecting optimal weights. So what are these weights that will optimize the relationship between Y and X? Now, the relation between Y and X could be as simple as a linear relationship where Y pred equal to W0 plus W1X. The W0 and W1 are the weights. The weights which optimize this relationship. So it could be a simple linear relationship, or it could be a very non-linear or more complex relationship like what you see here. Irrespective, the goal of machine learning is trying to come up with a mathematical formula between Y and X, given this optimal choice of weights. What are these weights that will optimize the relationship between Y and X so that we can come up with a formula as you see here on the screen? That's the goal of machine learning system. So how exactly machine learning system finds these optimal weights? Well, it starts by initially guessing these weights, the W0 and W1. Usually you have much more weights. For the example, for demonstration purposes, I'm just giving you 2 simple weights here. But think of complex relationship between y and x with lot of coefficients, lot of parameters also called weights. So initially, machine learning system guesses these weights and then tries to come up with some relationship and predicts y. So at the first go, the prediction which the machine learning system is making, given x and the weights, it may not be optimal. It may not be that close to y, right? So how far is the prediction from the actual y, actual label? Well, that's the measure of loss. So machine learning computes this loss, the difference between y, the prediction which the machine learning system is making, and the actual y. It then takes this loss and adjusts the weights. And then it calculates the relationship again and predicts a new y. It measures the loss again and it adjusts the weights again. And this process continues and it keeps on iterating until the loss is zero. What happens when the measure of this loss is zero? That means the y pred is very, very close to y. That means machine learning system has figured out an optimal relationship between y and x by selecting the optimal weights. And we call the machine learning system has learned and it has become smarter. So once the machine learning system is become smarter, has learned the relationship between y and x, you give it a new image, let's say image of cat, and it will correctly tag it or label it as cat. So this is the intuition behind machine learning, how a machine learning system works, how it comes up with its own rules on a very high level. Okay, in the next slide, let's look closer at something called data representation, which will help us in understanding how deep learning becomes different compared to machine learning. Okay, let's jump into the next slide. To understand the concept of data representations, let's take a look at a binary classification example. Let's say we want to design a system for binary classification using human intelligence instead of machine learning. Let's say the binary classification problem we want to tackle would be something like predicting whether a website URL link is spam or non-spam. So how would we approach this problem using human intelligence? Well, we'll start with the input data, of course. For predicting whether a website URL link is spam or non-spam, let's say we want to use two features. The first feature would be the URL length itself. And the second feature would be the frequency of special characters and hyphens. What about the labels? Well, the labels would obviously be the non-spam and the spam class here, represented by the white symbol and the pink symbol. Let's plot the raw data and see how it looks. So as you can see here, both the negative classes of the non-spam and the spam classes are plotted here. So now the goal is to come up with a rule that can separate these two classes. Well, in this simple example, we can come up with something like a straight line as you see here with the dotted line. The equation is nothing but x1 plus x2 equal to 10. And with this, we can come up with a rule for predicting the classes, the y class. And x1 plus x2, if it is less than or equal to 10, it's a negative class, it's non-spam. If x1 plus x2 is greater than 10, it's a positive class, it's a spam class. Okay, simple enough. See, but what if we can transform this data, the raw data, into a different format, such that coming up with this rule becomes even more simpler? So for example, what if we can do a coordinate change? Instead of using x1, x2, what if we can define a new coordinate system, x1 new and x2 new, and then transform this data and present it in the new format, new coordinate system? So the better representation would be, to see this data in this new coordinate system, x1 new and x2 new. As you can see here, it's still the same data, except we transformed it a little bit. That makes it that much more easy to separate, the negative class and the positive class. See, the rule would now be even more simpler. Something like x1 new less than or equal to 0 is negative or non-spam. x1 new greater than 0 is going to be the spam class. So this is the idea behind data representation. Transforming the original data in such a way that it makes it easier to come up with a classification rule. Here we solve the classification problem using human intelligence. Let's take a closer look at the idea of data representations in the next slide. In the previous example, using human intelligence, we have come up with a coordination change and transformed the existing data, which made it much more easier to come up with an even simpler machine learning rule. But what about more complex examples, like let's say digit classification or face recognition? Can we still come up with explicit handwritten computer executable image transformations? Sure, to some extent, we can. But see, the resulting handcrafted rules would be very, very brittle. It would be a nightmare to maintain them. Any variations of the data, the carefully thought out rules would break, and we have to keep on coming with new transformations, new rules linked to the previous rules. So the question might arise, what about if we can automate this process of input data transformation and rule searching instead of us trying to do it by hand? Well, machine learning does exactly this. Machine learning combs through a predefined set of operations called hypothesis and will try to come up with this data transformation and the corresponding rules. So it starts with the raw data, maybe do some simple transformations, come up with the rules, measure the loss, adjust the weights, and iterate the process until the loss is minimized, and the machine learning system has identified an optimal rule for the task at hand. Okay, so the problem is this. Problem with standard or traditional machine learning algorithms is that they aren't usually creative in finding these input data transformations. They only comb through a predefined set of operations or a limited space called hypothesis space in trying to find these optimal data representations which will enable a better rules. This is where deep learning shines, with a deeper take on learning more creative and more meaningful input data transformations compared to standard machine learning. Let's take a closer look at the deep in the deep learning. First of all, deep learning is a subfield of machine learning, particularly a branch of machine learning algorithms called neural networks. Deep neural networks is what gives the name deep learning. The deep in the deep learning is all about learning successive layers of increasingly meaningful representations of the input data. Unlike traditional machine learning, or which is also called shallow learning, where the focus is to learn maybe one or two layers of input data representation or input data transformation. For example, logistic regression. Modern day deep learning, however, involves tens or hundreds or even thousands of successive layers of deep data representation. These layered representations are nothing but models called neural networks, literally stacked on top of each other. You can also think of deep learning as a mathematical framework for learning these increasingly creative, meaningful, deeper layers of data representations. So how do the data representations in deep learning actually look like? To understand this, let's look at a deep neural network for digit classification. Let's say we want to build a deep learning system that can automatically classify different raw images of digits into 10 different classes ranging from 0 to 9. Well, let's start with a single image of digit 4. Instead of directly trying to map the image of 4 with the corresponding label 4, what deep learning tries to do is it will convert this original image into more meaningful data representations through multiple successive layers and then tries to predict that the image actually belongs to label 4. In this example, we're using 4 different layers. So how does the original image transformation actually look like in each of these layers? Let's take a look at a real-world deep learning model in action to understand this. As you can see here, the original image of 4 has been transformed into increasingly different yet more meaningful and useful representations in each of these layers, which will aid in predicting that the image actually belongs to label 4. Think of deep learning like an information distillation process, where original information goes through successive filters and comes out increasingly purified, if I may, or maybe more useful in trying to predict the given task at hand. In this case, predicting that this image belongs to the label 4. So to recap, what is machine learning? Well, machine learning is a branch of AI, or rather the phase of AI that is trained rather than explicitly programmed. Machine learning tries to map inputs X with answers or labels Y. And as we have discussed earlier, a machine learning system needs to see a lot of this data X and Y, before it can come up with its own rules. So how does this data look like? Well, it starts with input data X, and traditional machine learning algorithms may transform this input data into 1 or 2 layers. Hence, the traditional machine learning algorithms are typically called shallow learning. So it looks at input data, transform data with 1 or 2 layers, and then the labels Y, and then the machine learning system tries to come up with its own rules for predicting Y. Basically trying to come up with a mathematical formula or equation for predicting Y given X and an optimal selection of weights called W. So in a nutshell, machine learning starts with the input data X, transforms the data into 1 or 2 layers, generate rules for predicting Y, measures the loss between the predicted Y and the actual Y, adjusts the weights, and then iterates this process until the loss is minimized, when we can say that the machine learning system has learned and become smarter. Then you give it a new data X, and it will try to predict what the corresponding label would be. So similarly, deep learning is a branch of machine learning. It's a particular set of algorithms within machine learning called neural networks, which also try to map X and Y. Except the difference is a more meaningful data representation through multiple successive layers, right, which transform input data X before trying to predict Y. So deep learning also needs to see a lot of data. How does this training data look like? Well, it starts with the input data X, which is transformed into more meaningful or creative and increasingly useful data representation in many different layers. As you can see in this example, 4 layers. And then the deep learning system looks at the labels Y. And then it still tries to map or come up with a mathematical formula or equation predicting Y given X and an optimal selection of weights W. So just like machine learning, deep learning is also an iterative process. It starts with input data, but it transforms the input data into more meaningful data representation through successive layers, generates the rules for predicting Y, measures the loss between the predicted Y and the actual Y, uses this loss as a feedback signal to adjust the weights, and continue the iterative process until the loss has been minimized, where the deep learning system is said to be smart and learned. Thank you so much for watching this video. Hopefully the video was able to demystify some of the core technological concepts related to AI, machine learning, and deep learning. And hopefully it gave you a little bit better understanding, a little bit deeper intuition as to how all these technologies are related. If you like this video, I would really appreciate if you can please like, subscribe, and share. And also, please comment in the comment section and let me know what other concepts within the field of AI, what are the tools and technologies that you would like to learn. I will try my best to make more interesting content related to AI concepts, tools, technologies, and some of the latest developments that are happening in this field so that everyone can take advantage of this transformative technology. Thank you so much. Please stay tuned.